Hey everyone, welcome back. Hope you're doing well. In this video, we're moving into Lesson 2 of Module 6. We'll be looking at how schedule crashing, like working overtime and adding more workers, can affect productivity. This video will focus on overtime work. Let's take a look at the learning objectives. Number 1, we'll learn how to calculate productivity loss due to overtime and crowding, which are two common methods used for crashing a schedule. Number 2, we'll go over how to estimate the cost of schedule crashing. First off, why does schedule crashing cost money? And what exactly are those costs? Well, you can think of schedule crashing like choosing express delivery. You're speeding things up, but it comes at a cost. One of the main costs is productivity loss, or in other words, a drop in efficiency. When people work overtime, or when more workers are added to a task, they often don't perform at the same level. Mistakes happen, coordination gets harder, and output per person can go down. There's also the issue of higher pay rates. To speed things up, you might need to pay workers overtime or bring in more experienced labor at a premium. If you're adding extra workers, you'll likely need more tools or equipment to support them, which also adds to the cost. And finally, to keep things moving faster, you might need to get materials delivered sooner than usual, and that often means paying extra for expedited shipping or priority handling. In this class, our cost estimation for schedule crashing will mainly focus on productivity loss and pay rates. Crashing costs depend on the crashing measure you use. As we learned in the previous lesson, there are different ways to crash a project schedule, like working overtime or crowding. In this video, we'll focus on the cost of overtime, while the cost of crowding will be covered in another video. Alright, let's get into the details of overtime. One of the main reasons overtime costs money is because of efficiency loss. This means that during overtime, we get less work done per hour. This diagram illustrates the relationship between overtime work efficiency and the duration of overtime. As shown, the loss in efficiency is typically minimal when overtime lasts only a few days. However, if overtime continues in an extended period, for several days or weeks, worker efficiency declines significantly. So, when you overuse overtime, even though workers are putting in more hours, the actual output per hour starts to drop. And this drop in efficiency doesn't just affect productivity, it also drives up costs. That said, extended overtime can still be effective in specific situations, such as during critical project phases, looming deadlines, or unexpected disruptions, when the cost of delay outweighs the loss in efficiency. The key is to use it strategically and sparingly, not as a default solution. Now, let's take a closer look at how to estimate overtime work efficiency. Here's the formula. Efficiency equals 100% minus the number of days worked minus 5, plus the number of hours worked per day minus 8, all multiplied by 5%. Or 100% is efficiency based on a regular 40-hour work week. That's 8 hours a day, 5 days a week. Again, days refers to the number of days worked in a week, and hours is the number of hours worked per day. So, as the number of days and hours increases, the efficiency decreases. This formula gives us an estimate of how much efficiency drops when we move from regular time to overtime. Now, let's apply the formula using an example. We'll calculate the work efficiency and efficiency loss for a worker who works 10 hours per day, including 2 hours of overtime, over a 5-day work week. Substituting the values into the formula, efficiency equals 100% minus 5%, times the sum of extra work days, 5 minus 5, and extra work hours, 10 minus 8. This gives us an efficiency of 90%. The efficiency loss, therefore, is 10%. As you can see, even small increases in work hours beyond the standard can result in a noticeable drop in overall efficiency. Now, let's talk about overtime effective hours. Effective hours refer to the actual productive hours worked during overtime. For example, if a worker is working overtime at a reduced efficiency rate, the number of hours they actually produce work in that time is less than the total hours worked. This is important as it can tell you non-effective hours, the time that's paid for but doesn't translate into meaningful output, which can significantly impact overall efficiency and cost effectiveness. To calculate effective hours, we multiply the efficiency percentage by the total hours worked. Now, let's continue with example 2, building on example 1. We'll calculate both the effective hours and the non-effective hours for this worker. We use the formula above. Effective hours equals efficiency percentage times total worked hours. In this case, the worker works 5 days a week, 10 hours each day. So, to calculate effective hours, we take the 90% efficiency we found in example 1 and multiply that by 5 days and then by 10 hours per day. When we do the math, that gives us 45 effective hours per week. Next, let's calculate the non-effective hours. We know the total hours worked per week is 50 hours, 5 days times 10 hours. So, to find the non-effective hours, we subtract the effective hours from the total hours. Non-effective hours equals 50 hours minus 45 hours. This gives us 5 hours per week. So 5 hours each week are considered lost due to reduced efficiency during overtime, time that's being paid for but not fully productive. Table 11.1 in the textbook provides the overtime efficiency and effective hours based on the number of hours worked per day and the number of days worked per week. These values are calculated using the formulas we've already covered. So instead of doing the math each time, you can simply refer to this table to quickly look up the overtime efficiency and the corresponding effective hours. For example, if you work 9 hours per day for 5 days a week, according to this table, the total worked hours would be 45 hours per week. Your efficiency would be 95% of the regular 40-hour week. And your effective hours would only be 42.75 hours, leaving 2.25 hours as non-effective hours. It is time spent working without producing meaningful output. Now we come to one of the most common problems in construction management: estimating the amount of overtime needed to crash a particular activity. For instance, let's say you have a crew of 6 workers, and based on the project schedule, you need to shorten the duration of an activity from 4 weeks down to 3 weeks by using overtime. The question is, how many days per week and how many hours per day will the crew need to work during that 3-week period in order to meet the new schedule? To solve it, we start with the normal schedule. The activity is planned over 4 weeks, with a crew working standard hours. So the total effective work hours are 100% efficiency times 40 hours per week times 4 weeks. That gives us 160 effective hours in total. Now, you need to crash the activity, meaning shorten the duration from 4 weeks down to 3 weeks. To do that, you'll need to apply overtime. Let's define E as the number of effective hours required per week over 3 weeks. The total effective hours will be E multiplied by 3 weeks, which equals 160 hours under normal conditions, as the total amount of work remains unchanged. So, E equals 160 divided by 3, which gives us 53.33 effective hours per week. At this point, we go to table 11.1 in your textbook. This table gives us the effective hours based on the number of hours worked per day and the number of days worked per week. From the table, we look for options that meet the required 53.33 effective hours per week. The closest match is 9 hours per day, 7 days a week, which gives us 53.55 effective hours. This means the crew has to stay at work longer each day, and even work through the weekends. As you can see, they're working 63 hours a week, but only about 54 of those hours are actually productive. That means around 9 hours each week are being paid for without real progress being made. That's why crashing the schedule often ends up costing more. All right, now let's take a look at overtime cost. Overtime cost is the extra labor expense that comes up when we try to speed up a task, like crashing the schedule to finish work earlier. To estimate it, we first need to calculate the normal labor cost. That's just the regular hours worked, multiplied by the regular pay rate. When we add overtime into the mix, things get a bit more involved. The total labor cost now includes both the overtime hours, paid at a higher rate, and the regular hours at the standard rate. So, to find how much extra we're actually spending on overtime, we take the total labor cost with overtime and subtract the normal labor cost. The calculation above is for one worker. To estimate the total overtime cost for the whole crew, just multiply it by the number of crew members. Let's apply this to example 4. This continues from example 3. Now, let's calculate the total overtime cost. We have a regular labor rate of $12 per hour, and for any hours worked over 40 hours per week, the overtime rate is $18 per hour. From example 3, we know that the crew is working 9 hours a day, 7 days a week, totaling 63 hours per week, to shorten the schedule from 4 weeks down to 3 weeks. First, let's calculate the normal labor cost per worker for 4 weeks at 40 hours per week and a rate of $12 per hour. The normal labor cost totals $19.20. Next, let's calculate the labor cost with overtime for each worker. The crew is now working for 3 weeks. Each week, they work 40 hours at the regular rate of $12 per hour, plus 23 hours of overtime, which is the difference between 63 total hours and 40 regular hours, at a rate of $18 per hour. So, the labor cost with overtime per worker is $2,682. Now, let's calculate the overtime cost per worker. We subtract the normal labor cost from the total with overtime, $2,682 minus $1,920. That gives us $762. Finally, with 6 workers, let's calculate the total overtime cost. 6 workers multiplied by $762 equals $4,572. This is the total extra labor cost you'll need to pay for crashing the activity from 4 weeks to 3 weeks. Is it worth it? Well, that depends. To make a decision, you'll need to conduct a cost-saving analysis, as we covered in another video. All right, let's move on to the final example. Example 5, which is the most comprehensive one in this video. A contractor has a crew of 20 workers on the job site. Each worker is paid $12 per hour for regular time and $18 per hour for overtime. Now, due to delays in the project, there's a serious risk of missing the contractual deadline, and that comes with consequences. Under the contract, there's a liquidated damages clause, which means the contractor will be charged $4,000 per day for every day the project goes beyond the agreed completion date. To avoid these penalties, the contractor is considering a change in the work schedule. The new plan is to have the crew work 12 hours a day, 5 days a week. This adjustment is expected to save 10 days on the overall schedule. So now we ask, is this a cost-effective solution? To answer that, we'll need to compare the additional labor cost of the extended work schedule against the potential savings from avoiding the liquidated damages. All right, let's walk through the solution and see if working overtime really makes sense in this case. First, let's look at the normal schedule. Let's say the original project duration is X weeks. Under normal conditions, the crew works 40 hours per week, so the total effective work hours would be 100% efficiency times 40 hours per week times X weeks, which gives us 40X total work hours. Now, let's look at the overtime schedule. The contractor wants to save 10 days, and since the crew works 5 days a week, that's the same as cutting off 2 full weeks. So the new schedule becomes X minus 2 weeks. With the new plan, the crew works 12 hours a day, 5 days a week. That gives us 60 hours per week, but only 48 hours per week count as effective working hours based on table 11.1. So now we have this equation. The total effective hours of overtime schedule, 48 hours per week times X minus 2 weeks, must equal the original total of 40X hours. That gives us 48X minus 96 equals 40X. Solving for X, subtract 40X from both sides, and we get 8X equals 96, which means X equals 12 weeks. So the original schedule was 12 weeks long, and the shortened duration is 10 weeks. Let's now calculate the labor costs. Normal labor cost per worker, 12 weeks times 40 hours per week at $12 an hour. That gives us $5,760 per worker. Labor cost with overtime. Now we're working 10 weeks with 40 regular hours and 20 overtime hours each week. So each week, the cost is 40 hours at $12 plus 20 hours at $18. That totals to $840 per week multiplied by 10 weeks gives us $8,400 per worker. So what's the overtime cost per worker? 8,400 minus 5,760 equals $2,640 extra per worker. Now multiply that by 20 workers. That gives us a total overtime cost of $52,800. Now compare that to the potential savings. If the contractor avoids 10 days of liquidated damages at $4,000 per day, that adds up $40,000 in savings, which is less than the cost. The overtime plan would actually lose the contractor money instead of saving it. But here's an important point. Even though it's not cost-effective on paper, some contractors still choose to go ahead with the overtime schedule. In some cases, maintaining a good relationship with the client or preserving the company's track record for on-time delivery is more important than the money lost in overtime. Completing a project on time can be a key condition for winning future contracts, especially from high-value clients. Also, completing early would benefit the cash flow as project completion unlocks final payments and retention releases, which can offset the overtime cost in ways not reflected directly in this calculation. All right, that wraps up this video. We covered how overtime impacts productivity and how to estimate both overtime hours and costs. Thanks for watching, and I'll see you in the next video. Goodbye.